I think I've given you, I've talked to you before, but just to remind you, I was born in the United States, and of course my first language is American English. I live here in Slovenia, and this is the 9th grade here in Slovenia, and of course your main language is Slovenian, and this is an English language class. Now I know in just a few days you guys are going to graduate, and you'll be out of the school. Congratulations. And I know you're excited about that, but I just ask that you please give me your attention for 45 minutes, because I will be talking to you about something that will be more and more an issue in your lives, okay? And that is the question of global warming. Or in Slovenian we say, "Pojav topla grede." Okay? And we've been on the moon, and we have robots roaming around on Mars. We just sent a satellite past Pluto. And all of this is to try and understand the Earth more. Okay? And the more we understand the Earth more and what's going on, the more afraid we're becoming of this question of global warming. The Earth is really a beautiful place floating out in space. And it's so beautiful because its average temperature is a nice 15 degrees centigrade. Okay? So poprečna temperatura na svetu je 15. To je prvi vprašanje. But the Earth's atmosphere is very thin. It's only about 15 kilometers from thick. Okay, now I have it. So from here to here is about 15 kilometers. And we in the world have almost 7.5 billion people. And because there's so many of us, we're starting to change the chemistry of the air. Now the temperatures have been stable on the Earth relatively for about 8,000 years. But recently they've been starting to go up pretty fast. Last year was the hottest year in recorded history, 2015, and the hottest year before that was 2014. And for the first time last year, temperatures rose by 1 degree above what they were in 1850, which was the beginning of the Industrial Revolution. So based on this climate change, the United Nations in 1987 formed a group of scientists from 150 countries, thousands of scientists working together. And they issued a report in 2014, and they said that humanity faces a profound challenge and that the Earth will be a different place in your lifetimes. They are estimating that the temperature on the Earth by the end of this century, when you're really old, will be between 1.4 degrees hotter or 5.8 degrees hotter. And if the temperature goes up by 5.8 degrees, the Earth will be a much different place than we know it today. So, no matter how much it goes up, Europe is going to get hotter, especially in southern Europe. So that's the end of the introduction. And now we ask, why is the Earth getting hotter? And the reason is because of toplogredni plini, or greenhouse gases. The sun heats the Earth, and so the land and the air gets warmed up, but most of the energy from the sun is reflected back into space. But in the air are natural greenhouse gases, which capture the heat and keep it at a nice 15 degrees centigrade. But we're putting more of those gases into the air, and we're building like a piece of plastic over our heads, like a greenhouse. And you know how hot it is in these greenhouses. The main gas is carbon dioxide, which comes from fossil fuels. But also methane and nitrous oxide are very powerful greenhouse gases. So when we are making electricity from petroleum or gas or coal, or when we're making steel or plastic or heating up our homes or driving gasoline cars, we're making carbon dioxide, and the pigs and the cows and the meat that we're eating is producing methane and nitrous oxide. And cement is producing a lot of carbon dioxide. And also when we are destroying the rainforests, we are destroying the ability of trees to absorb the carbon dioxide and put it back into the ground. And we've destroyed 20% of the Amazon rainforest so far. The earth is very sensitive to carbon dioxide. And if you look back in the history of the earth, 500,000 years ago, in green, the level of carbon dioxide was going up and down between 300 and 200 parts per million. And the temperature of the earth was going in synchrony with this, up and down, the same as the carbon dioxide. So here's a question for you. How do the scientists know what the level of carbon dioxide was 500,000 years ago? Are they just guessing? Or are they looking at the ice in Antarctica? Are they looking at tree rings? Or are they looking at fossils? What do you think?
Are they just predicting?
Hmm?
Can't they just predict what happened in history?
They predict, yeah. But how do they predict? This is how. They dig out an ice core from Antarctica, and the deeper down is older history, and in that ice are little pockets of air from a long time ago, and they analyze it, and they find out how much carbon dioxide was in there. Now, a lot of countries have done something about greenhouse gases, especially in Europe. The greenhouse gas emissions of Europe have fallen by 20%, and even the United States, it's slowed way down. We see a lot of solar panels and windmills and more efficient cars all over Europe and also the United States. But even with that, carbon dioxide is not only increasing, it's accelerating. And last year it passed the 400 parts per million. And don't forget, for the last 500,000 years it was between 200 and 300, and now it's over 400. And the reason for this is that we are still producing carbon dioxide. It stays in the air a long time, but China is producing 28% of all the carbon dioxide in the world now, because it's developing. And China is using coal, which is the dirtiest of all carbon fuels, to fuel its development. It uses half the coal in the whole world. So here's the question. What evidence do you see from around the world that the climate is changing? What do you see? There was hardly any winter, right? Last year was almost no winter. And you see the trees are blooming more, earlier and earlier. When we're making wine, we're getting the grapes a month earlier than before. So, if we take a look at this evidence here, the mountain glaciers are melting, there's extreme weather, oceans are warming, mass extinctions are happening, and the Arctic Sea is melting. So let's take a look at this evidence. This is a glacier in Switzerland in 1909 and now. This is a glacier near Grossglockner in Austria in 1938 and now. This is the Muir Glacier in Alaska in 1941. Now it's almost a big lake. In the Himalayas, this glacier melted back from 1968 to there. In Argentina, in the Andes Mountains, this glacier looked like this in 1928. It looks like that in 2004. So the glaciers are melting in the mountains. There's extreme weather. Right now, in northern France, in 24 hours, it rained as much as it rains in 6 weeks. And so the river next to the Louvre Museum rose up and it almost flooded the museum. Now, luckily, it's starting to go down. The strongest typhoon in history wiped out part of the Philippines in 2013. In 2012, Hurricane Sandy came into New York and flooded it. It was 1,500 kilometers in diameter. These are extreme storms, okay? There's also growing droughts and lack of water, especially in northern Africa, the Middle East, northern India, and northern China. And this is going to just keep getting worse by 2050. There's already a 20-year drought in southwest United States. This is a picture of Lake Mead, the largest reservoir in the United States, and it's only 38% full. Okay, but also the oceans are warming and they're becoming more acidic. We know that the Earth is mostly ocean water, and 90% of all the heat from global warming is going into the ocean. It's not staying in the air, it's being stored in the ocean. So you want to know where the heat is? It's in the top 700 meters of the ocean. And as the ocean surface is getting warmer, it's evaporating more into the air, and then we're getting the strong extreme storms because of that. But not only that, the carbon dioxide in the air is dissolving into the ocean, and it's making the oceans Volkisla. So the pH is falling. And this warmer and more acidic oceans are killing the coral reefs, where we find 25% of all marine diversity. Already 20% of coral reefs have died, and maybe all of them are going to die this century. Mass extinctions that are starting. You see how many species are starting to die, okay, since 1880, but more and more. And 1 million species that are predicted to die by 2050, all these guys, okay? 50% of primates. Primates are like gorillas, great apes, monkeys, chimpanzees, our cousins. They're at risk of going extinct. 30% of morski pest, or sharks. 32% of amphibians, java. 12% of birds, 25% of all plant species. There's been 5 mass extinctions in the history of life on Earth, okay? Maybe some of them had to do with meteors hitting. But now scientists think there's a 6th extinction happening right now, but this is different because the human beings are causing it. Finally, the Arctic ice is melting, and the reason is that the Arctic is warming up twice as fast as the rest of the Earth. And this is the question there. It's the Arctic is the hottest place. It's warming the fastest. It's warmed up 2 degrees since 1980. The Arctic means the area around the North Pole. Okay? In 1979, the ice was all the way around there. But recently, 40% of it had melted. This is great if you own a shipping company, because the ships are already starting to go from Japan and China to Northern Europe across the Arctic Sea. Now this is great if you own an oil or gas company, which I know a lot of you own companies like that, right? Because they discovered a lot of oil and gas underneath the Arctic Sea, and they're just waiting to go take it out. But it's terrible. This is terrible for the Earth. Because when the ice is there, look at this, 85% of all the heat from the sun gets reflected off the ice, and back to space. But if it's blue water, 93% of that heat gets absorbed into the water. And so global warming is going to speed up because of that. But luckily, when the ice is floating on the Arctic Sea and it melts, it does not raise sea levels. Okay? It does not raise sea level because it's already there, it's already floating, the weight is there. But rising sea levels maybe is the major issue of global warming in the long run. Okay? Rising sea levels. This is a big, big problem. For 8,000 years, sea levels have been stable. But if we go back just 20,000 years ago, this was in the middle of the last ice age, and the ocean was 140 meters lower than it is today. That's a lot. It was enough so man could walk from Europe to Great Britain, or they could walk from Asia to North America, and that's how the American Indians got there. But recently the oceans have begun to rise again, and they've risen about 20 centimeters, okay? They're rising for 3 reasons. The oceans are warmer, so they need more room. They take warmer oceans, are bigger ocean. Mountain glaciers are melting, but the final reason is Greenland and Antarctica. Greenland has 10% of all the ice in the world, and Antarctica has 89% of all the ice. And slowly they're starting to melt. If we look at Greenland, Greenland is the largest island in the world, and it's covered by 2 to 3 kilometers deep ice. Greenland is more lednik. And it's starting to melt. Now the question is, if Greenland would melt, how much higher would the oceans be? You give me an answer. A, B, C, or D? If all of the ice in Greenland would melt. There's A, 5 centimeters.
No, B.
Huh? B? B, 1.5 centimeters. That's a pretty lot. 7 meters. As tall as from the ground to here. The ocean would rise just from Greenland if it melted. And Greenland is starting to melt. Look, from 1979 to 2007, it was just melting a few weeks of the year on the south. But in 2012, it was melting all around the whole coast, north and south, for like 3 to 4 months. And also the inland Greenland was starting to melt. Up on Greenland in the summer, there's tens of thousands of lakes, Jezera, that are formed. And these lakes have rivers, and the rivers of melted water go down cracks into the ice. For a long time, the scientists didn't know where is the water going. Now they know. It's coming out these fjords, out into the sea, and it's raising the sea level. And all of this ice in Greenland is getting holes in it. It's becoming like a honeycomb, like bees are in it or something. And it's getting thinner and weaker. Now we look at Antarctica, which is not an island, it's a large continent. Antarctica has 89% of all the world's ice. Antarctica has 3 parts to it. It has the Antarctica Peninsula, which points towards South America. There is the Larsen B ice shelf. It has West Antarctica, where the ice is on top of a bunch of islands. And it has East Antarctica, which is at a higher elevation. Scientists said, no, this is not going to start melting even this 21st century. But in 2002, the Larsen B ice shelf broke up. There it is. This is a big satellite photo. In 40 days, it broke and it all went out to sea. It started to melt. In 2007, they said that this part of West Antarctica was starting to melt. In 2013, one of the biggest glaciers, which is called the Pine Island Glacier, it cracked off, and a huge section fell into the sea and went out and melted. And that destabilized 6 other glaciers in inland Antarctica. This goes hundreds of miles, hundreds of kilometers in. And then scientists said that 6 glaciers in Antarctica are breaking up, and that is unstoppable now. Now this year, 2016, they said another problem is going to happen. Not yet, but maybe in a couple more years. Look, this is Antarctica. These are ice shelves. They're 200 to 300 meters high, and they're sitting on the ocean floor. If it gets a little bit warmer, it's going to start forming lakes and rivers on the top, and it's going to refreeze, and it's going to crack those things, and they're going to, big chunks of this ice, they think are going to fall into the ocean. So that maybe by the end of this century, the oceans will be rising like this much every 10 years, they say. Just probably from Antarctica. So in 2007, they predicted that oceans would rise between 20 and 40 centimeters. In the prediction of 2014, now they say the oceans will rise between 75 and 180 meters. So by the end of the century, maybe in your lifetime. How much is 75 centimeters? Can you show me? Like this much, right? Something like that. All right, so how much is 180 centimeters? That's a little bit taller than me, all right? I'm 170. Whoa, stand up. Yeah, yeah, okay. All right, good. All right, sit down. Can you imagine if the ocean were that much more? What is this going to mean? If by the end of your lifetime, maybe the oceans are as tall as he is, that much deeper. It means a lot of cities and people are going to start drowning by ocean water. A lot of cities are in danger. Miami and all of southern Florida. These are some of the homes in Miami Beach. Okay. New Orleans already was under the water during the hurricane in 2005. New York City, part of it went underwater in the Hurricane Sandy in 2012. Parts of northern China have been underwater because of floods in the ocean. Bangkok, Thailand, the land is just sinking and the ocean is rising. Bangladesh has over 150 million people, and it's very low. They're predicting this will go underwater, as will the Nile Delta. In Alexandria, it's right on the ocean, you know, with a lot of people living there. Indonesia could lose 2,000 islands. And oceans rising it's not going to stop this at the end of the century. It's going to keep rising. And computers' predictions now, just from Antarctica, by the year 2500, well, we're not going to live that long. But oceans might be 13 meters taller just from Antarctica. It depends on how much we want to go. All right, we've discovered that the oil and gas companies, they know where everything is already. They know where the coal is. They know where the petroleum is, and they know where the gas is, okay? And if we're going to burn, just leave it in the ground and burn just 5% of it, Antarctica will be okay. The ice. If we're going to burn half of it, most of the ice on the Antarctic is going to melt. And if we burn it all, the ice is practically gone on Antarctica. So, if all the ice on Greenland, Antarctica, and the mountain glaciers melted, how much higher would sea levels be? This has been in the news.
Yeah, like
7.
75.
Yeah, that's right. So yeah, these are the possible answers. And it's 70 meters. And this means, this is showing you what it would be if 60 meters, the ocean rose 60 meters. See, the United States borders would change. The oceans would come 100 miles inland on the east coast. All of Florida would be underwater, and all of the southeast United States. In Europe, the Netherlands is gone, Denmark is gone, and a big part of England, this part of Italy is going to be under the water. In Asia, all of northern China, Bangladesh, and northern India would be underwater. Okay? So obviously this is a big, long-term, gradually getting worse problem of the oceans rising if we keep using all the carbon fuel, you know. But a more immediate problem might be this one here, hunger and conflict. The world's population now is 7.5 billion. By the middle of this century, it's going to go more than 9 billion. The most people are in Africa, and then the Middle East, and then maybe North and Central America. That's where the population is growing the fastest. Exactly where it's the hardest to grow food, and where the water is the shortest, is the most people. Okay? And also, the global production of food is not really keeping up with the population growth in general. And so the UN says extreme weather may lead to a breakdown of food systems. We might see more of this. We don't want to see this. But also, the civil wars of Sudan and Syria and Nigeria all started in large part because of big droughts. People couldn't feed themselves. And these civil wars have destroyed even more the ability of farmers to feed the people. And so in Europe in this last year, in 2015, we had 1 million immigrants, refugees coming, and it created a lot of political problems, right? Around the world there was 20 million, okay? And here's a question. By 2150, how many more migrants does the United Nations predict? So there was already 20 million, another 20 million, 50 million, 100 million, 200 million, or 500 million. Nobody had a clear answer, but the UN says 200 million. 200 million more, in other words, 10 times more migrants than we had last year are going to be roaming around and looking for a place to eat and live. And a lot of them will probably try and come to more developed countries. So no matter what, a hotter planet is a more unstable planet. So this is a global problem. What can we do about this? Al Gore was the US Vice President. He's done a lot to make us aware of global climate change. He said we have to change the energy, transportation, agriculture, and forestry systems in the world and shift to a low carbon pattern. That's a lot of changing. If we just look at the energy, we're getting energy from 5 places. Okay? This is like electricity. The first 3 is coal, gas, and petroleum. Alright? And those are all producing carbon dioxide. Less than 15% is from renewable energy, and 7% is from nuclear power. So we need a lot more renewable energy, more nuclear power. We need to capture carbon. Renewable energy is coming from the water, the sun, and the wind. But we've dammed up almost all the rivers in the world. We're finishing damming our little Sava River, and we're going to get a little bit more electricity. Solar energy is increasing very rapidly, and the cost is coming down. The same thing is happening for the wind, energy from the wind. So we need a lot more wind and sun power. A lot more. We also need more nuclear power. This is controversial, but it has lots of electricity and no carbon dioxide, and a lot of 13% of the world's electricity comes from nuclear power. The problem is these plants are dangerous. Like, for example, a tsunami in 2011 hit these nuclear power plants in Japan, and 3 of them melted down, and they sent radiation all across the Pacific. But still, the newer nuclear power plants are very safe and can produce a lot more energy, and they're planning to build a lot more. We need to learn to catch the carbon before it goes in the air. It's a new technology. It's very expensive, and it's not going anywhere yet. And we need to increase the amount of insulation in our houses, and we're going to see a lot more electric cars. Okay, that's coming. So how long does carbon dioxide stay in the air? Once it's in the air, how long does it stay? Several months, 20 to 200 years, thousands of years, or hundreds of thousands of years? There's 2 answers. Okay. First, about 2/3 of it dissolves into the ocean and makes the ocean more acidic over 20 to 200 years. But the last 1/3 is the problem. It takes hundreds of thousands of years for this to get absorbed into the trees, to turn back into rock, turn back into coal. That's where it came from. Okay? So it doesn't disappear very fast. We need international action, and we had it in Paris in December. All the countries in the world and all the leaders in the world had an emergency meeting, and they came up with a plan for each country to try and reduce greenhouse gases, and it's going to be reviewed every 5 years. They want to limit the temperature increase to 2 degrees, ideally 1.5. The problem is it's already 1 degree, okay? And even if all these plans are carried out, it's going to go up 3 degrees more, if they do what they say. So we're running out of time, okay? Really, we have to get off of carbon fuels entirely, because they stay in the air too long. Once the Earth changes, you can't put it back together. So that's why they say we're facing a profound challenge in your lifetime. Maybe in my lifetime too. Is this the future you really want to have? The combination of high temperatures and humidity is projected to compromise normal human activities. For weeks on end, anyone working outdoors could risk life-threatening heat stroke. And you think this is at the end? This is in 2100? It happened in India already. On May 16th, the temperature in India, northern India, was 51 degrees. Nobody was working outside that day, and thousands of people died. But now, on the optimistic side, this is a statement from Bill Gates. You know who he is, right? I'm so optimistic about the world's ability to make a miracle happen that I'm willing to make a prediction. Within the next 15 years, and especially if young people get involved, I expect the world will discover a clean energy breakthrough that will save our planet and power our world. We need the sun and the wind, and we need something else that we have to discover. So what he's saying is that young people have to get involved, and saving the Earth's climate is really your responsibility for the 21st century. And my responsibility as much as I have to live, but I'm not going to live to the 22nd. So, congratulations on finishing this talk, which is in American English. Ta predavanje ni tako enostavno, okay? And je na tuj jezik, okay? It's in a foreign language and it's complicated, but I think most of you have understood a lot of what I have to say. And it shows you that your English language has advanced a lot here as you're going to graduate from Režģīsavas Nova Škola. So congratulations for that. And I don't know of any other 9th grade in the United States where I could give this talk in a foreign language, not in English, like if I gave it in Slovenian. They wouldn't understand. So this is your advantage. You're far ahead of where, this class is far ahead of what American 9th grade would be. So thank you for listening and learning, and best wishes to you as you go forward in your life.